Yeah, as well. All right, questions. Any question? Can we go to whiteboard? You want? You can also, by the way, you can also share your screen as well. You don't?
Okay.
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 Which way would you write? Shall we choose whiteboard now, or?
Oh yes, whiteboard. It's fine.
Whiteboard would be fine. Okay. Do you have any particular question to discuss today?
Yes, I still have another sheet there.
Yeah.
What about the? There was one that said.
Are you looking for the old the reference you sent to me?
No, it's another sheet.
Another
yes.
sheet. Okay.
It's about the to find the coefficient of x. I'll write it down. Can I write it?
Yeah, you can write. Yeah, is it still binomial? I remember we're talking about binomial.
Yes, it's,
yeah. Okay.
Yes, it's binomial.
Can I write the question here? So what is the question?
I can't draw. Here it is.
Okay, doesn't matter. Take it to write. You can annotate, right? Annotate.
I think it. No, it's just,
okay.
It's x.
Yeah.
It says to say the. Oh, this is really bad.
Yeah.
It's to say find the coefficient of x12.
Yeah.
In the.
To the power 12.
x12 and the expansion of 2x to the power of 2. Okay, maybe I can write it quick.
It's x to the power of 12. Yeah, that's huge.
Yeah.
That's huge. Yeah.
To x12 to the power to minus. This is a fraction. This is supposed to be a fraction.
A fraction.
Yeah, to the this binomial. And the little sign means like the power.
What is the question? So x, what does x represent? Oh, that's why you type it. Okay.
Yes.
So that is can we rewrite that is x 2 multiply or 2 square, right? 2 square.
Yeah, 2 squared.
Minus 1 over x, right?
Yeah, minus 1
and
over x.
all of them to the power 12 altogether, right?
Yes, and I need to find the coefficient.
This x. Oh, I forgot. This x, right? This x squared.
Oh yes, okay. It's 2x squared. Yes.
Okay.
And I need to find
the coefficient. Yes.
Of 12. Yes.
All right.
Of x12.
X12. Well, that's a bit different, right? This is different from the formula we have. Do you remember the formula we have? We have the xy. If you wish, you can use xy, right? That is the formula we have, you know. In binomial theory, we can write the formula. That is a Cn, okay? And I can use k here because k is a summation for these variables for the summation. That is x to the power of k, remember? And y to the power of the a minus k. That's what we know. Now, how if you compare these two, there is some similarity, okay? Can we rewrite that? That is 2x squared minus 1 over x, okay? There are some similarity, okay? There are some similarity. What are they? So n from here we can see this is n, so that is looking for. See what is we know n equal to 12, right? N equal to 12. Yeah. So from here we can see that n equal to 12. Okay, that's good thing. But how about x? If you just compare them directly, say, can we say x in here? Can this is x here? Can you see this stuff? Oh, in this case, can we call this a? Can we call this a? So basically is a. You see, you can write a polynomial in different notation. In this case, because we have trouble, we have the different, we have similar, we have the same notation here. So that's why I rewrite this by use x, instead of use x, y, I use a and b, right? So this algebra is okay because you can rewrite that. You can rewrite that with any letters, okay? So therefore, compare with that, what is our a here? What is our b? That would be the hint for you to solve this puzzle.
Okay.
Yeah, go on.
I have a question because we've been learning this in class, and this is I don't know if you can see it.
Yeah, I can enlarge that. I can go back to the camera. Okay, I can go back to the camera. Yeah, that is a formula. Can you show me again? Can you show me? I copied. So that is that's the notation for the this is notation for the combination we discussed. It's just put the n different corner. That's all. Same.
Yes.
Yeah. Okay.
Yes.
Okay.
But why is because n minus r is in the a instead of the b? So you did.
I would double check what I check my what I'm writing here. So we got a. This is k.
So
This
shouldn't that one be n minus k?
n minus k. This is n minus k, right?
But why isn't in this one the first one n minus k?
This is n minus k. Yes, that's k
But
to power. What is
yes,
can which one are you talking about? This one or this one? This one or this one?
they're both the same. This one, the first one, this
First
one.
one, the first one. Yeah.
Yes, but why is it in this one the n minus is
the formula is this formula different from the one you show me?
Yes, it's instead of the n minus r.
Can
the
you
n
show me
minus
again?
k.
Can we just show me again? Okay, I will just go back to stop sharing. n minus 1 b is 1. Oh, that's interesting. That's interesting. So that will depend on how do you define a and b. Okay, it doesn't matter. It doesn't matter. I show you why it doesn't matter, because it's just two. You can you go back? It doesn't matter. It's algebra. You see, that is a trick here. So it doesn't matter which is x, which is y. Can you see? For example, yeah, you can see that you can rewrite this as b plus a. Okay.
No. What I mean is the n minus r. So here you've done for b the n minus k is the b to the power of n minus k, but in this one the a is to the
that doesn't matter. You can I can show you now. Can you see the change now? Can you see the change? K to 0 to n. That became a b. Okay. That became k. Okay. That become a. Can you see the difference? Nothing changed. Because it's because why? Because a plus b equal to b plus a. You see.
Okay.
So therefore, a plus b, any power, any is the same. Can you see?
Yes. Okay.
Ordered is the order. Oh, another thing the teacher give you is they have just this. They prefer to write this one. Can you see? That's only difference. But I just prefer to write it down here. That's all. You see, different, slightly different notation.
Yes. Okay.
Okay. Do you want to try the one? I give you.
Yes, I'll try.
Yeah.
Okay. Let's see. Do I try it on the whiteboard? It's really hard.
Are you able to write? Do you have proper writing? Do you have? Can you write?
Yes.
Yeah.
Yes, I can
you
write.
See, I write. I without a touch screen. I just write on the pad. That's all.
Okay. Can I do it on? I can't touch screen. Can I do it on a piece of paper and then give you the answer?
Okay. Okay.
Well,
perhaps in the long run, perhaps you need to have the the simple writing pad. You see, so that I can see what you write. It's important for me to watching to observe students writing when you solve the problem. If I can see what you're writing, what you solve the problem, I can I can identify. Yeah.
I think I think my mouse will help me.
Did you use a mouse? Do you have pen? Perhaps next time you can buy the pen. Okay, the pen, the writing. Okay. Pen. Yeah. Okay.
Okay. I'll use the mouse for this time because I think
matter. You just tell me what is A. Can you say what is A? What is B? If you want to use the formula.
Yes.
Okay.
A is 1 minus 1x.
Yeah. Yeah, you can call that. Yeah, no problem. You can call that. Yeah, you can call that.
And 2x 2.
Yep. Yeah, no problem. You can do that. You can do that. So the next thing is just substitute into the equation. Okay, that is a formula. Anything important, I use this frame here. So you just put into the formula. Okay. So you can substitute this to replace this A and B by these two. I just show you the method. Okay. Do you want to show? Do you want to see how to do that?
Yes, please.
So therefore, because that's once we have identified this one, what we can do is that we can just write here. So basically, in this case, in that way, so we have, so therefore, right in here. So therefore, we can obtain 2x squared plus 1 minus x to the power of 12 or equal to, we just copy it, okay? This is ck, so this is ck. Do you have to find all the coefficient or just some of them?
No, just the coefficient of x to the power of 12.
Oh, you found this 12. Okay, the highest.
Yeah.
The highest. Okay,
Yeah.
the highest. Okay. Okay, that's simple. Can we just go back here? So basic power cell. Can we just put the k here? This is the formula. K equal to 0 to n to 12 is 12, right? And a can change. A will become negative. Can you see? Negative 1 over x to the power. Can we use the first one? To k, okay? Multiply, what is b? B is 2x squared multiply n minus k. Can you see? Now, can we connect the number which is 12? How can we get the number 12 of x?
Yeah.
Yeah. Oh, that's a bit tricky. Yeah, that's a bit tricky.
Yeah.
Okay. We have put the x together. Can we just do some manipulation? So basically this term, I just focus on these two. That will equal to, can we say that equal to negative, okay, negative 1, okay? Can you see over xk? That is the first term. The second term, you got 2 to power of the n minus k, right? And time x to n minus k. Can you follow me? So we got a number and x. Okay, next one, can we combine these two? Combine these two. We need to combine these two. Simplify, you see? Okay, which rule can we use? Which rule can we use? If you have, so the basic rule is if you have a to power of the n and a to power of the n, what is the result? Index law.
Index law is a.
A, yeah, what is to the power? What is index law? You forgot?
Yes, a
Minus n, can you see?
Yes, a n minus n. Is it?
All right. You perhaps you forgot this one.
Yes.
Anything important, I use this origin frame, okay? Just remind you, it's essential. Okay, we just do some algebra, okay? Can we just leave this alone? Can we just do this? This is how to say, this is a skate, this is scratch. So can we solve this first? So that would be the x, the base is x, okay? The base is x, but this index will be 2 times n. I expand that first, okay? I expanded 2n, 2k, and minus k, can you see? So what is the outcome? What is the sum? Yeah, 2n. Yeah, 2n here.
2n minus 3k.
Yep, that's right. 3k. So we get x power we get x of this power. Okay. Okay, that since it's getting settled. So we are looking for the power, the coefficient of this particular. We are looking for this power, this coefficient. Okay, we are looking for this particular term, so x to the power 12. Okay, so the question is, what is the coefficient, right? This is question, okay? This is question. So what can we do? The key to solve the problem is, can we just net that equal to 12? That's all. Okay. So what is n, by the way? What is n?
12.
12 too. Okay. So from this equation, what can we do? Can we just write down here? So can we just go here? A little bit crowded here. Can we just go down all the way here? Okay, we solve the problem now. So can we just net 2n minus 3k equal to 12? So 3k, so therefore 3k will equal to 12 plus 2n. Or k can be solved, can you see? K can be solved, that's 12. N is 12, can you see? N is 12, that's plus 2 times 12. Because N equal to 12, do you agree? This N equal to 3. Can you see the result now? Can you see the solution?
Yes, it's divided by 3.
So what is the K?
It is 36 divided by 3, 13.
13. Is it 13 exactly?
I think so. 13.
Double check that. That's important. So 12. 12. Now it's 12. 12 multiplied 3. Yes, 12. It's 12. My answer is 12. How can you get 13?
Oh no, because isn't it 2 times 12?
Yeah,
Plus
2 times 12. Yeah, plus 2 times 12.
So
12.
isn't it 24?
Or you can factorize. 12. Can we factorize that? Can we factorize the numerator? That equals to 12. 1 plus 2. Can you see? Divided by 3. That equals to 12. Be careful. You see, that will determine the answer. You want to slow down a little bit, okay?
Yeah.
Okay, I just use this point here. Can you see? This is correct, okay? This is correct. This is condition, okay? This is correct because we need this term. We need this is equal to 6. We need the index equal to 12, okay? Okay. So we solve the k. The formula for the k is 12 plus 2n divided by 3. Okay? We solve this equation. Can you follow me?
Yes, but I don't get why it's 12.
Okay, 12 multiply 24, right?
Oh, it's multiplication.
Multiplication.
12
24.
So it's 12. It's 12 times 24.
Yeah, that's a bit. That's a bit. It's a bit algebra with the numbers. Can you go to next one? Okay. So you got 12. Sorry, not 12. 12 multiplied 2 multiplied 12. Okay, divided by 3. What I do is factorize. Can we factorize this? Can we factorize that? Factor. Cofactor. Factorizing. So we got 1 plus 2 divided by 3. Or, if you wish, that give you 12. Okay. Or if you wish, can we just 12 plus, say, 12 plus 24 divided by 3? What is the answer? That's your way. 12.
12.
Okay. So that's important. Okay. It's 12. It's not 13 because you know what? Next, we're going to use this. It's important. It's vital because these differences, one is odd, one is even. Okay. Notice what? Let's just go back. Not finished yet. Let's go back. So we know that k is 12. Okay. K equal to 12. Okay. Now, what would be the coefficient? That would be this one. Can you see? That would be the coefficient. This would be, I will use these colors. That would be the coefficient. Okay. When that is coefficient we're looking for. Okay. Can we write it down? Next one, next page. It's negative k 2n minus k 2. Yeah, that's coefficient. So therefore, after all this calculation, we have the c, the coefficient we're looking for, will equal to -1 to the power of k, right? K or n, we double check. It's k, okay. And then multiply 2 and n minus k. Double check. Yes, we get there. So what can we do now? What is n? What is n? N equal to 12. Do you 12. Agree? What 12. Is k? 12. 12? Yeah. 12. Can we solve this problem now?
12, so 12. 12.
Oh
Isn't
yes,
it
you need.
1?
Yeah, this is 12. Is this 12, right? How about second one?
It's 0.
0. Wow, that's simplified a lot, isn't it? So what is the 0 to the power 0? What is 2 to the power?
1.
Yes,
1.
you're right. Therefore, yeah, that we got 12. What would be this answer?
1.
Yes, why? Why? Why is 1? You have
Because
to proof.
because it's
I show you. I show you. I know it's 1, but when you're doing math, you have to convince people. Okay. Here I jump to this one. Can you see that? Here I use another law, which index law. This power. This another index law. What would be the answer? Do you remember this index law?
N times n.
Time or yeah, you are right. Multiply, yeah, multiply, yes. Okay. Since you are not sure, I use a frame here. Okay. I hope you will pay attention to this basic rule in algebra. It's called axioms with a basic rule in algebra. Okay. It's called algebraic axioms. Did your teacher talk about axioms?
No.
Axiom is just a basic rule. From there, we can solve the problem as long as we can use this basic rule. Okay. Okay, just return to the question. Why did I do that? Why did I use this trick? Why did I use this trick?
To explain to me why.
Because since the highest in the primary school, we know this is equal to positive 1, okay?
Yeah.
So the positive 1 to the power 6. Can you see that?
This one, yeah.
Yep. Okay. I think, yeah, that's a little bit of algebra today. Good.
Yeah.
Is that
But
the answer is different? Different answer? Yes. Well, if the answer is different, we have double check. Okay. Today I just show you the method. Okay. I just show you the method. What is the answer?
Yes.
We can do double check.
It's this.
Can you write it down? What is the answer?
Yes, I can write it down. It is. Where is it here? It says that this is the answer. So 12.
12. Oh, huge number. That is a combination, right? It's combination.
Yeah, this is how it's. This is the what it's saying to a.
Oh, we need to go back to the
-1. Well, that's the answer according to. That's the coefficient.
This is 4. Is this a 4?
Yeah, yes, this is 4. Yes.
If that is 4, can we write it as 1? Okay.
Okay. Yes.
Okay. Now, basically, they identify this is a 4. On the first, basically, this coefficient is at k equal to 4, right?
Yes.
So this imply k, that what the pickup from this one is k equal to 4. So basically, where we have, say, we have a plus b here, right, to the 12. And then one of term will give us a, this is their notation. This is equivalent. This is notation for the combination formula. Now, in this case, that would be the a to the power of the k, called the 4, right? This particular term. So this is just one of them. And b will be 12 minus 4, right? So this is just one. This is just one of them. This is just one of term. But I'm not. We'll check. We'll check if that give you 12 to the power of 12. That is the issue. Okay. We'll double check. We'll double check because we got the case different. Our case different. Can we go back? Our case different. What's our k? K is 12. Can you see? K is 12. So basically, if we use this notation here, basically they say this is they're still different from the, apart from coefficient, they got 2 here to the power 2, right? Interesting. Interesting. Yep, we just go over double check. Let me see. if this is a coefficient, they got k equal to 4, but we don't. So perhaps they have done something have been done beforehand. If they put, but it doesn't affect the result, right? Can we just, I will just follow our notation here. A is negative, okay, negative x, okay, double check. B is 2 to power, are you sure this is correct? Are you sure this is correct?
Yes, it's 2x squared. I'll show you on the camera if you want.
Let's just check, have a look at the camera. Yeah, we need to be
It's D.
2 power x to the 12. Yeah, that's right. D, right?
Yeah.
D. Okay.
Yes,
Yeah,
and it says to find the coefficient.
Okay, we double check that. Yeah, I know that. We'll double check that. You see, something might be wrong when we just when do substitution. So this problem is by substitution. So this is correct one. So we assign this part is our A, and we assign this is a B, the 2 to power. Yep, we substitute that one. That's how we substitute. That we have substitute this one. This is K. Doesn't matter which is which. So we got. So this term can be written as negative 1 to the power k, and this will be the n minus k, so it's 2 to the power of n minus k, okay? And so this one, x to the power 2 multiply the n minus k, yes, and the denominator will be the k x to the power of the k, all right? So far, so good. Then we just double check that one. When we combine the x here, we just use this 2 to n plus minus 2k minus k. This is wrong. This is wrong. You see, we got a mistake here. Can you see? 2k minus k will become k, not 3k. Can you see? This is 1. We got a mistake here. Can you see that? So this is not 3k. I just highlight, that's all. Okay, this should be 1. This should be 1. So that's why I'm not surprising we got a different answer. Okay.
Why is it 1? Isn't mine negative 2k take k?
Oh, let me see. You are right. You are right. It's 3k. It's nothing wrong. We are right. We're not wrong. Okay, you are right. We are 3k here. 3k here. 2n, 2k, yes. Negative k, yes. Okay, well then that is right. Okay, there's nothing wrong here. I just overlook this. This is right. Now, in this way we solve it. We're looking for the power. We need this equal to 12. We need this equal to number equal to 12, and we solve it. Plus x plus 12. Oh, hang on, this is wrong. This is minus 12. Sorry, this should be minor. We make a mistake here. Minor mistake. Can you see?
Where?
Here.
Why is it minus 12?
We must 12 to here it became minus. So this, I know the result now. Can you see? That's negative 12. So that is will be 4. Yeah, you are right. Not surprising. So this if this is negative, see, can you see the arrow happen here? 12. Can you see this should be 12? So this should 12. Then that is answer will not 12 but 4. Okay, that makes sense.
Yeah, but why is it negative 12?
This is original. Can you copy that? 2n minus 3k equal to 12. Can we solve that? Can we solve the k? That is original.
So we can move.
That's
it would be
original.
negative 3.
Yeah, that could be negative 12.
We can move. Let's see. Can I try something else?
Yeah, we found the arrow now.
So it would be, I could do this, negative 3, negative 3k equals 12 and take 2n.
Yeah, you can do that way. Yeah, you can do different way. Yeah.
And then bring the 3 over here.
Yeah.
Which would this make a negative divided by negative 3?
Negative 3, if you wish. Yeah, you can negative wish. Yeah, because that is where. Anyway, they got a positive integer at the end, right?
So it would be 12 would be -4 take 2n, right?
Well, if you have done that, then this must be disappear. So this is cancelled, right? You divide it.
And then -4 plus -4 plus take 2n.
Yes.
Which is 2 times 12 is 24.
It's 4.
Which would make it. How?
No? How?
I don't know.
Let's go back. Let's go back. Okay, let's go back.
Yes.
2n minus 3k. So let's just do that. So we have this making mistake here. 2n. We got what is our answer? So we got 2n minus 3k equal to 12, right? Okay. Can you just plus 3k on both sides? And we got 2n equal to 12 plus 3k. Okay. Can we minus 12 on both sides? That is what we do. That's 2n minus 12 equal to 3k. All right. So therefore,
why does it need to be moved over to negative? Why does it have to go to the other side? Why can't it stay?
Doesn't matter. Doesn't matter. Doesn't matter. Okay. You can try. You can try. I just show you this how I got my answer here. It doesn't matter. So that's the 2n minus 12. Okay. So that divided 3. That's what is n? N is 12. What is 12? 112 minus 112 equal to 112. We still have 112 here. Equal to 4. Okay. Now, alternatively, yeah, I follow your thought. Okay, we don't have to go. The algebra is a symmetrical. You can just 3k equal to 12 minus 2n. Can you see? We minus 2n on both sides in your way. Okay, in your way. So therefore, we have the k we're divided by -3. So we divide it by -3 on both sides. Okay. So we got 12 minus 2n. Can you see that? That is k. So what is 12? 12, n is 12. Is 2 multiply 12. Can you see? Divided by -3.
So that would be
-12 divided by -3. Do you agree?
Yes, and which would be 4. Yes.
Positive 4. Why you find it intriguing? Because the same, you can manipulate an equation by add or subtract, doesn't matter. But at the end of the day, I tell you why I do this. Why did I did slightly different way than yours? Why? Because we are needing to solve. We needing to solve the k. Okay.
Okay.
So therefore, we better make it positive in the first place. Can you see?
Yes.
Okay. Because ultimately we're looking for the k, right? Okay, that can be solved the puzzle. So basically, if you return to this question, so we have jumped from here. So this is not wrong. So this is not right. We have go up. Can you see? So that be -1 to the power of the 4, right? K equal to 4. And 2 is 12 minus k. Can you see it? Minus 4. Okay, that's return to your answer. Can you see? That would be the 2 to the power of 4. Can you see? Or 8. That's what I'm looking for. That's back to your answer. Can you see? If you combine these coefficients, so basically this one, so this particular term will equal to 12 over 4. This is the combination formula. Multiply this formula. See, multiply this 2 to power 8, and that's x to the power of 12. So if you just pick up the coefficient, this will be the coefficient, will be identical to your answer.
Okay. Perfect. Yeah.
Yeah, I think this is this is toward the end. You see that you must have chosen this from the final few, right? One of the most challenging one.
Yes.
Okay. Let's go to that next one. Next question.
Maybe. How about how
Okay.
about this one?
Yep.
It says to expand and simplify.
Can we just have a
Expand and
look
simplify.
at your question? Yeah.
Yes, it's B. It says
It's a
to
B.
expand
Yeah.
and simplify.
Square root of 5. Is that square root of 5? Square
Yes,
root of
it's a
5
square root of
plus 2 to the power of
plus
4. Yep.
to the
Okay.
power 4. Yes,
Okay. So, okay.
and then it says hence find the value of 2.01 to the power of 6.
Another one.
No, I think it's following this one. It's the oh no wait, no
Okay.
mind. No, first let's do the one to the
Yeah.
power.
Square root of
And
5.
then
Okay.
the
Let's
other
go
one.
to square root of 5
Yes.
first. Okay. So root of 5. And then let's have a look. So this question is, oops, different color. So the question is square root of 5. Sorry, square root of 5 plus 2, right? 2 to the power 6. What is power?
To the power of 4.
4 only. Oh, simple. Just by substitution. So what is A?
Yes,
What
I
is
need.
B? What is A? What is B?
A is
Yeah. So
power
from,
of 5.
yes. So N equal to 4. A equal to whatever. Doesn't matter which is which. B, we just follow the order. Okay. All right. So what can we do? So basically, we can use a formula now. Can we use a formula now?
Mm-hmm.
So therefore, square root of 5 plus 2. We use a formula. Can we just copy the formula first? That's the C. I use their notation. If your teacher told you this notation, that is the notation for the
Sum.
for the combination.
Oh yeah.
The same thing. So basically, NK denote the same thing as C and K, and also determines NK. Can you see? They are identical. They are identical. The formula is, do you remember? That's n factorial, k factorial, n
To n
minus k
minus k.
factorial. Okay, that represent the same thing. Now, represent, can you put a here? A is k, k from 0 to n to 4, right? In simple, it's for 4. That's b is n, that's 4, n is 4. In this special case, minus k. All right, so that's what we're looking for. Do we have expand? Do we have expand them? Next
Yes, we
one.
have to
Yeah,
expand.
you have right. This is a 4. Can you see?
Yes,
Can yeah, go on.
I
That's
have
cool.
this means a sum. Oh wait, you can see my. This means the sum, right?
Sigma means the sum. This means
Yeah.
the sum. Yeah.
So why? I'm sorry, I'm a bit confused now. Why is the sum there? Are we trying to find the sum? Oh yes, we're trying to find the sum of all of that to be able to find the answer. Is that
That's right. Because a binomial theory allowed you to rewrite the binomial into the sum, the polynomial into the polynomial. Okay.
Mm-hmm.
So that's why there are always more than one term depending on the n. Okay. This that work that you can tell that number just looking at the Pascal triangle. That's another way to work out that how many terms would you get if the n is fixed, is given. Yeah.
Okay.
Do you want to continue? This
Yes,
is
please.
5. This is 5. This is 5. So they can square root 5. Can we rewrite that first? Can we read it as 5 to the power of the fraction? Can you see? That's square root 5. Yes, square root 5. Do you agree?
Yeah.
And then we put the power will be the k. Can you see? How about the second one is 2, right? And second part, which I write it directly, that's 4 minus k. All right. So what we can do is because each k will change from 0 to 5, you have 5 term. You have put the 5 term together. Okay, now a bit of time. Can we just to do that? Can we fix this first? Can we simplify this first? We simplify this by 5 to the k divided by 2, first term. That little bit simplified. But
Yes.
we can't do anything. Okay. Well, in that case, we have to expand that according to this according to 5 term. You want to do that?
Yes. Yes,
So
it says to expand and
yeah, that has pair example. Can we just simplify that? You can put them together, okay? Can we say k equal to 0? What would be k equal to 0? That equal to 4, 0, multiply 0. Can you see this general term? This is general term. So k equal to 1 will be 5 to the power 0, okay? And to the power of 4th. That's first term.
yes.
How about second term? As 4,
Good.
1,
To power
okay?
1,
Yes, that's
5,
5.
1.
5 to the half, right?
Yeah.
The half. And how about this term? 2 to power 3.
Oh, 3.
Okay. Okay. Yeah, it is a bit tedious, but that's how you do it. 4, 2. All right. How about the 5? 1.
5.
1
1.
divided
Uh-huh.
by equal to 1. You don't have to write it. It's 1. It's 5. How
Uh-huh.
about this one? It's just subtract
2,
by
2.
2. Okay.
Yeah.
Yes, it's getting simpler now. To the power of 3, they got 4, 3, 4, 3 over 2. Can you see? 3 over 2. How about 2? Just 2, right? Just 2.
Okay.
Last one, k equal to 4. So the 4, 4. I can tell you what, the 4, 4 are the same. So 4, 1 will equal to 4, 4. Okay, they are symmetric. These are symmetrical. I'll talk about later. Can we just finish this one? That would be 5 to the power of 5 squared. And just 0. That's just 1 because that is a 2, 0. Okay.
Okay.
There are some symmetrical things. Perhaps you know. If you don't know, you can try to prove that. So these ones, so these two are the same, are the same thing. So these are the same. So these are the same, and also these are the same. Can you see these are the same? So what you need to do, you have to, if you then you have to spend some time, probably 10 minutes or so, to work out each of them. How about the 4 over 1? How to calculate that one?
Isn't it 4?
So
4
this is 0, this is
factorial.
0, yeah? That's
Uh-huh.
4
It's
factorial.
4
3
over 1
factorial,
fact. Oh, you
it's
take
just
this.
4, it's just 4,
4, yes.
yeah? How about, we need to find one more, how about 4, 2? 4
It's 4
factorial,
factorial
yeah?
over
So 2
2
multiply
factorial
2, yeah, just 2
or
by
2
2, right?
factorial.
Yeah, 2 to 4
Yes.
divided by 4.
Yes.
What would be that answer? That'd be 4 is cancelled. That'd be 3 equal to 6. Do you agree? Is that
Yes, it's
equal to
equal
6? Equal to
to
6?
6. Yes.
Actually, you can use you can if that's a now you can use a Pythagoras. No, you can use a Pascal triangle to work out as well.
Mm-hmm.
Okay, so
So,
we have counted that. We don't have counted this one. The only thing we need to count is this last one. That's 4, 0. What would be this answer? 4
1.
factorial 1. Are you sure? Yeah.
Yeah,
4 factor
perfect.
4
Yes.
factor. Yeah, that's equal to 1. Yeah, okay.
And 1.
So we got this one is equal to 1, equal to 1. This equal to 4. This equal to 4. That equal to 6. Okay. And do
Yes.
some housework to put everything together. Are you
Uh-huh.
allowed to use a calculator? Can you use a
Yeah.
calculator? Yes, yes.
Yeah. Yes.
So next one you have to put all these together, all these number together, all these value
Okay.
together. Can you write down here? This just can we write the final answer? So this was the first term. The first term will be the 5. It will be 2 to power 4 because that's equal to 1. Okay, and equal to 1. And second term, the coefficient is 4. So you got a you still got a square root here. So you got a square that is a 2 to power of 5 square root of 5. You see that? You can double check that. You can double check that. And this term will be 6 times 5, 30. Okay, that'd be 30. That'd be the 30 multiply 4. Multiply the 4. Okay, it's 100. 120, right? Oh, you can do that. You can do it afterward. Doesn't matter. It's just numbers now. How about this one?
It's 4 times 2.
Yes, 3. That is 4. Yeah, it's 4 times 2. Yeah, 12 is 12, right? And 12 multiply this one, so 5. 5
Isn't 4
squared.
times 2 8?
This is the you 4. No, this 4 times this 2 is 8. Yeah, you are right. Oh yes, you are right. Oh yeah, you are good at numbering. You are a good number. Good numerical. Good. Okay, now we have to rewrite this one. If you can use a calculator, you can stop here. Otherwise you get 5 multiply square root 5. Okay, square root 5. 8 multiply 5 to square root 5. The last one is 1. See, 1. That's equal to this equal to 1. So that is 25. And last one is 25. Then you have to put all these number together. It must be a large number, right? Because 2 to the power is 16, or 4 is 16.
It says this is the answer.
Oh, doesn't matter. You tell me the answer. That's so
160.
no, it's not important. Okay, it's not important. We just want make sure we got the right method. If anything wrong, if anything different from answer, you double check the method. That's all.
Okay.
It's not say when you solve the mathematical problem, or any problem in physics or chemistry, don't pay attention to the answer. Okay, you must convince yourself that I'm using the right method. Okay, if anything wrong, that must be due to my carelessness in calculation.
Okay.
It's not important. In order to the method is important. Okay, if you know the right method, that is half done. Or if you have if you wish, if you have calculator, you can put this number together. 4 16, right? That be 16. First one be 16, right? Because 2 multiply 2 multiply 2 multiply 2, that equal to 16. Yeah. So first term is 16. I just highlight this one. If you wish, put them together. So 5 3 is 16, not integers. And the second term is this power to 5. You have the 16, 30. This will be 33. You have this is 33.
33.
Yeah, 33 multiply square root 5. 33 multiply square root 5. That's wrong. This is 16. This is 16. 16. And the largest number would be 125, 120. That is the largest number among the term in the middle.
So,
it's not integer. Are the integer? Are the answer integer?
it's
not,
in
it's not integer.
It is. It's 161 plus 72 to squared to the 5 squared.
Yeah, you have 5 square. Yeah, you can't get rid of square. You have to use square root 5. Yes.
So I'm just gonna do 160 plus 16.
Yes. Right down here is 16 plus 25.
And then the true.
Sure.
I know how to get the 161. I'm just having trouble getting the 72 to the power 2 squared is 5.
Well, I suggest if you have time, you go back to this check. You can save this page, all right? And to see, because nothing can be wrong because as long as we got the right method, okay? So so that's how to manage your time, okay? If you found, you see, I tell you what, my students have 2 papers, old paper, okay? And we solve the problem together. And every time we got the wrong answer. And you know what happened? They got a different answer sheet. So don't waste your time. Okay, each time just make sure that the method is correct. And if you want to increase that reliability, then you do some numerical exercise. That's all.
Okay.
Any question? We still have a few minutes.
Yes. Can we do one more? Let's see, I think it's.
Yeah, I'll show you the method at least. Yes.
I'll show you. It says.
Yeah.
Can I quickly go back to the
Go back to whiteboard. You can write here.
Yes,
you can write. Yeah.
How do I go? Thank you. So it says to find. It says. Hence, find the. Oh wait, expand. It says to expand. I can expand this.
Yeah.
But then it says to.
Power.
I had 2 plus x to the power of 6.
What's this number? What is number?
6.
6. Okay. Did you mean that 2 plus x to the power 6?
Is that what? 6. Yes.
Yeah.
And then it says to find the value of 2.01 to the power of 6.
Do you want 2 point what?
01.
01. Oh, that's simple. That's simple.
To the power of 6.
Yes. So you need to find this formula 6. You find this formula 6 first. Can we find this formula first?
Sorry, hold on.
So what is A? Okay, just do this routine. What is N? Equals 6, okay? What is A? Is 2. What is B?
X.
X. Okay, so that will allow us to build this equation. So A2 plus X power 6 will equal to, I use sigma, okay? I use sigma form. Sigma form is compact. That is a C, that is a C, that is a 6 to the K, K from 0 to 6, all right? And 6 term with 2 to the power of K, and multiply X, X what is the power, what index? That is 6 minus K, 6. Okay? Yeah. So you have 6 term, so you have to be patient, you have to expand that. Can we expand that? Or you can do it afterwards. Can we expand that? That is 6, 0. That is 0 is 1, okay? That is X. I multiply X to the power of 6, okay? That's first term. Second term would be 6, pick up 0, pick up 0, pick up 1. That be the 2 to the power of 1, okay? That be X, that be minus 1, 5, okay? The next one will be 6, pick up 2. You got the 2 to the power square, and multiply X to the power of the 4, right? Let's just continue. Let's continue. 6 period of 3. 6 period of 3. That be the power to the power of 3. Multiply the x to the power of 3. Can we see? It just decreased by 1.
Yes.
Okay, then what next? Well, if you can write, I don't have to write. Okay, next time if you have pen, you can write. So that's 2. 2 to the power of 4. Multiply x to x squared. Okay, one more. And then, 2 more. 6. So this 2. No, that 2. So this is 4. Sorry, this is 4. Okay, this is 4. This is 4. This is 5. This is 5. 2 to the power of 4. Oh, what's wrong? 5. Yeah, nothing wrong here. X 1. Okay. Okay, the last one is 6 pick up 6. That be the 2 to the power of 6. And x 0. You don't have to write anything. X 0. Okay. Okay, that's it. So that is the formula. Okay, that is the formula. Now this is the first part of that. This is the first part of that. The second, how about the second part? Can you see the similarity between these two expressions? Between these two expressions, what is the similarity between these two? Can you see any similarity and difference?
Between which one? This one and this one?
And this one, because we need to solve this problem.
They're all to the power of 6.
It's all to the power of 6. And what is difference?
That one is a binomial and the other isn't.
Isn't? So what can you do? You can rewrite the numbers. Can you rewrite the number? Can you say, how about 3? Can you say, if you have the 3, oh, sorry, I'll use this, okay. If you have 3, can you write it as 5 minus 2?
Yes.
You can always rewrite the letters. Rewrite a number. Yeah.
Can it be, sorry,
Yeah. Can you rewrite the numbers? Yeah.
yes, can it be this? 2 plus 0.1 to the power of 6.
You are in the right track. Yes, you are right. Yes, right.
Sorry.
So what can you do?
2 plus 0.1 to power 6.
Yeah.
And
so
then,
you got formula. Can you see the formula?
yes, and then do I just substitute it into
Yes, you have fun. You have substitute x equal to this one in order to find this answer. Can you see? So you just make sure x equal to this. This is your x. This is your x.
Okay. X. Okay, so I just substituted into x.
Oh yes. Have fun. You have 6 terms. 10 minutes.
Okay.
If you have calculator, probably 3 minutes. Doesn't matter.
Okay. It's good. Okay.
That's. I think that is how you see. That's how you. Are you still studying binomial? Shall we discuss binomial next time as well, or do you have other type of question?
Next time maybe can we do physics?
Which subject are you studying now in physics?
In waves.
Yes, the wave. Okay. Oscillation, the wave, and the diffraction. Are you studying diffraction? Standing wave? Not yet. Or introduction?
Not yet. We started learning about simple harmonic motion.
Okay, we can start for simple harmonic motion next time.
Yes. Okay. Thank you. Yes.
All right, and see you next time. This time is okay. Is time Wednesday is okay?
No. Can we go? Oh wait. Next
Up to
week,
you. Up to you. Get back to.
So 1 sec. Today is Wednesday, Thursday, Friday, Monday. Can we do Monday next week at 5?